everyone. In this video, we will learn the application of a double integral. There are many applications, but we will discuss only two in this case. The first is area of the region. With the help of double integration, we can evaluate the area of the given region, provided we need to take the function as a 1. Means, if you take the double integration of function 1 over the given region, that will give you the area of that region. Secondly, if the function is of the form of xy, that is a surface that is not is equal to 1, in that case, if we take the double integration over the given region R, then this will give you the volume of the region beneath the surface z is equal to a function of xy and above the xy plane. Now let's understand these two applications of double integration with the help of examples. The first example is find the area bounded by the curve x is equal to y square and x plus y minus 2 is equal to 0. In order to find the area bounded by these curves, first we need to identify what exactly the region in this case is. Suppose this is a x-axis and this is a y-axis. This point is origin. First curve is x is equal to y square. As it is a parabola, we just need to identify whether this is an upward parabola, right side parabola, downside parabola or the left side parabola. How to identify this? A simple procedure. We just need to observe this equation. For any value of y in this case, x is always positive. If you take a value of y as a negative 1, negative square is positive. And if you take a y as a positive, positive square again is a positive. And hence x is always positive and x is always positive towards this side and hence it is a right side parabola but passes through the origin. We can name this as x is equal to y square. Second is x plus y minus 2 is equal to 0. We can write this as x plus y is equal to 2. This represents the straight line but does not pass through the origin. How to construct this line? First we will take a y is equal to 0. That will give you the x-intercept. When y is 0, the value of x is 2. Suppose this point is 1, so this point is 2. It will cut x-axis at 2. Now put x is equal to 0, y is 2. Indicates that it will cut y-axis at this point. Now take a line passes through these 2 points. So this is a line of x plus y is equal to 2. Now which one is a bounded region? From here we are getting a bounded region above the x-axis between these two curves. But that is incorrect because not mentioned that y is greater than or equal to 0. So we can also take the region that is below to this x-axis. But for that we need to extend this parabola. After extending the parabola, we are getting a bounded region between these two curves as this. Now we are in a position to find the area bounded by these two curves. For that we will take the double integration. Function is 1 dx dy. Or you can take double integration by taking function as a 1 first with respect to y then with respect to x. For that we need to observe the region as well. Suppose you want the integration first with respect to x. Limit for the x. Take a line parallel to the x-axis passing through this region from anywhere. So I am taking the line parallel to the x-axis from here as well as from here as well as from here. Now I have taken a 3 imaginary lines. You need to observe always in this case whether the entering curve for these imaginary line is same. Right now the entering curve is this pink color and that represents the parabola where x is equal to y square and that is always same for each and every 3 imaginary lines. So it means we can take the lower limit of the x as y square. Now we need to find the upper limit of variable x. For that we need to observe from where this imaginary line exit the region. This is exit the region from here, from here, from here. And this is a straight line. This straight line name is x plus y is equal to 2. But we need the value of x and that is equal to 2 minus y. This is how we are taking the limit for x. Now we need to take the limits for y. How to take that one? For that we are observing the shadow on the y-axis. Suppose you are standing over here and you have a torch in your hand and you are putting a light on this region. You will get a shadow from here to here. It means we need the intersecting point of these two curves in order to identify the values of y. When x is equal to y square and x plus y minus 2 is equal to 0, how we have identified the intersecting point? By substitution, or we can say by elimination of the one variable. Here I will take the value of x as y square. So we have y square plus y minus 2 is equal to 0. This is the quadratic equation. If it is a quadratic equation, means it has two roots. What are the two roots in this case? We can write this as y square plus 2y minus y minus 2 is equal to 0. This implies y common y plus 2, then minus 1 common y plus 2 is equal to 0. So this implies y minus 1 into y plus 2 is equal to 0, and this further implies y is equal to 1 or minus 2. Now where y is equal to 1? Y is 1 on the above of the x-axis, means here we have y is equal to 1 and here we have y is equal to minus 2. What are the corresponding values of x? As it is an intersecting point, means this point satisfies line as well as a parabola. Either evaluate the value of x from the line or from the parabola. When y is equal to 1, the value of x is 1. When y is equal to minus 2, the value of x is 4. But our target is to find the minimum value of y and x. And what is the minimum value of y as per this reason? That is this point. At this point, the value of y is minus 2. It means the lower limit is minus 2. As per this reason, maximum value of y is at this point, and from this point, the value of y is 1. Now, before finding the value of this area, let's observe what are the limits in this case. Now, to take the limit first with respect to y, then with respect to x, again we need to repeat the same procedure. We will take a line parallel to the y-axis passing through this region in increasing order. So I have taken a 3 lines over here passing through this region parallel to the y-axis. As per this one, you can observe the entering curve is always a parabola, whereas the exit curve is different. From this point to this point, whenever you will take an imaginary line, the exit curve is again a parabola. And from this point to this point, when you take the imaginary line, that imaginary line exit this region from the straight line. It means we are getting a two different upper limit for the y. So in this case, we need to split this region into two parts. How to split this one? You just need to observe from where this exit curve is getting changed. It is changed when we are started from the A point to B. After the point B, the exit curve is different to the point C. It means we divide this region into two parts. That is, this is the region R1 and this is the region R2. It means this integration is further divided into two parts. One is for the R1 and second is for the R2. Function is 1. Thus dy dx as it is 1, dy dx as it is. In this case, first we need to take the limit for the y. Now this curve is represented in terms of x. How to represent this curve in terms of y? From here, just find the value of y. This implies y is equal to plus minus under root of x. It means we have two different curves. One curve is a y is equal to positive of root x and second is a negative of root x. Which one is a positive of root x? That is above the y-axis. Why? Because above the y-axis, y is always positive. So from here towards the point B and moving further, this curve is represented as y is equal to root of x. whereas a curve from A to C that represents the y is equal to negative of root of x. Now let's evaluate the limits for y in the region R1. So take a line parallel to the y-axis passing through this region. In this case, the entering curve is this, and the name of this curve in terms of y is equal to minus of root x. So y is equal to minus of root x is the entering curve, and the exit curve is this white color A to B, and that is represented as the y is equal to positive of root x. Now what about the x in this case? Same procedure, we need to take the shadow on this variable, that is on the x-axis. Just we need to take the shadow for the region R1, not for the R2. In this case, this region starts from 0 and the maximum value is here, and this line is what? That is x is equal to 1 because the intersecting point is 1 comma 1, and in this case the value of x is 1. So the maximum value of x in this region is 1. It means lower value of x is 0 and the maximum value is 1. Whereas for the region R2, take again a line parallel to the y-axis passing through this region in increasing direction. The entering curve in this case is y is equal to minus root of x. Exit curve is a straight line. In this straight line, what is the value of y? Y is equal to 2 minus x. Now what about the x? For that we will take a shadow on the x-axis only for the region R2. In R2 region, minimum value of x lies here, and that is 1, and maximum value for this R2 region. When you take the shadow of this region, for that you need to stand on the top and put a light from the torch. Even stand at the bottom, put a light from the torch, you will get a shadow of this region from this point to this point. This point is what? In this point, what is the value of x? That is 4. It means the maximum value of x in this case is 4. So this is how we are taking the limit with respect to y first and then with respect to x in this case. So we just need to observe first whether we need to take with respect to x or with respect to y. In case we are getting a separate curves as an entering or an exit curves, then try to change the order of integration and then evaluate. So rather than evaluating this one, I am evaluating the previous term because that is comparatively easy. Now evaluate this one with respect to first x, then with respect to y. With respect to x, integration of 1 is x. Limits of x is y square to 2 minus y, and the outer integral limit as it is for the y, and here dy as it is. This is equal to this integral as it is. Substitute upper limit, this is 2 minus y minus lower limit, that is y square dy. This is equal to 2 into y because the constant integration is y. Integration of y is y square by 2, this negative sign as it is, negative of. Integration of y square is y cube by 3. Limit for the y is minus 2 to 1. This is equal to, substitute upper limit, that is 2 minus 1 by 2 minus 1 by 3 minus lower limit y is equal to minus 2. So 2 times of minus 2 minus minus 2 square is 4 by 2 minus minus 2 cube is minus 8 by 3. Simplify this, you will get an answer as a 9 by 2. Next question is, find the area bounded by this curve where x is greater than equal to 0 and y is greater than equal to 0. So for that, first we have taken the xy plane. This is the x-axis and this is the y-axis. Now we need to observe this curve. This curve is actually a parabola. If you observe that y square is equal to minus 2x. This is a parabola where x is always negative. How? When you take any value of y, maybe positive, maybe negative, the value of x is always negative. It means it is a parabola that is on the negative of the x-axis. But we have some additional term, that is a plus 4. So when you add plus 4 in this parabola, it means that is shifted towards the right side. Exactly, we don't know whether it shifted plus 4 units, maybe something else, but definitely it will not intersect at the origin. So it means that is shifted on the right side with some unit. Suppose we have this form. This is a parabola, y square is equal to 4 minus 2x. Now, in this case, we need to find the intercept first. What is the value on the y-intercept and x-intercept? Y-intercept means when x is 0. When x is 0, what are the values of y? The value of y in this case is plus minus under root of 4, that is plus minus 2. It means this intercept is 0 comma minus 2 and this is a 0 comma positive 2. Now when y is 0, in that case the value of x is equal to 2. It means it intercept on the x-axis at 2 comma 0 point. Now there is an additional curve, that is x is greater than equal to 0 and y is greater than 0. It means we just need to work only in the first quadrant. Hence we have this shaded region. Now we need to find the area bounded by these three curves. That is, in a first quadrant we need to find the area of this bounded region. For that we need to take the double integration of the function 1 with respect to x, then with respect to y, or take the double integration of the function 1 with respect to y, then with respect to x. In this case, let's take a limit first with respect to x. For that, we need to take a line parallel to the x-axis passing through this region in increasing order. In this case, which one is the entering curve? Entering curve is always a straight line. If you take a line over here or anywhere over the shaded region, entering curve is always the straight line and that is a y-axis. On y-axis, what is the value of x? That is, x is equal to 0. Exit curve is what? Exit curve is always this parabola, and from this parabola extract the values of x. That is, y square minus 4 is equal to minus 2x. This can be written as x is equal to y square minus 4 by minus 2, or we can write 4 minus y square by 2. It means the value of x as the upper limit is equal to 4 minus y square by 2. For the values of y, we take the shadow on the y-axis. For that, you need to stand here and take a torch, put a light on shaded region, and you will get a shadow on the y-axis from this point to this point. At this point, the value of y is 0. At this point, the value of y is 2. So if you evaluate a double integration by taking these limits first with respect to x, then with respect to y, you will get the area bounded by these three curves. Let's evaluate this. With respect to x first, what is the integration? That is x, limit of x is 0 to 4 minus y square by 2, and this integral y is as it is. In next step, substitute upper limit of the x minus lower limit of the x. Upper limit is 4 minus y square by 2 minus lower limit is 0 dy. Now evaluate the integration with respect to y. Integration of a constant is y minus integration of y square is y cube by 3, and this 1 by 2 is outside. Limit for the y is 0 to 2. Substitute upper limit minus lower limit. The answer in this case is equal to 8 by 3. Now in case you want the limit first with respect to y, then with respect to x, we need to take a line parallel to the y-axis. In this case, identify the entering curve. Entering curve is from where this imaginary line enters the region. That is always a x-axis. On x-axis, what is the value of y? That is 0. For the upper limit, find the exit curve. Exit curve is a parabola. From here, what is the value of y? Y is equal to plus minus under root of 4 minus 2x. Again, we have two different curves. One is positive and negative. Right now, whether this is always positive, always negative, or the mixed curve. Observe this. We just need to find the area above the x-axis, that is y is greater than or equal to 0. It means we are not dealing with the negative of this curve. So rather than taking a plus minus both the curves, we will just take only a positive curves in this case. Y is equal to under root 4 minus 2 times of x. What about the x in this case? We take the shadow on the x-axis. For that, you need to stand on the top. When you are standing at the top, putting a light on this region, you will get a shadow from this point to this. At this point, the value of x is 0, and at this point, the value of x is 2. So either evaluate the previous one or this one, you will get the same answer. Even in this case, the answer is 8 by 3. Next question is, find the area bounded by these two curves. First, we have taken the x-axis and y-axis, that is the xy plane. Now we will construct these two curves. The first curve is a parabola that is towards the positive of y-axis. As for every value of x, this y is always positive. It means it is an upward parabola. Next is y is equal to 4 minus x square. This is again a parabola. The base is y is equal to minus x square. Y is equal to minus x square means for every value of x, may be positive, may be negative, the y is negative. It means that is a downward parabola. Now, we just need to observe what exactly the curve is. In this curve, we need to add plus 4. It means that curve is shifted above because we have added 4. So, it means that is shifted towards the positive of y-axis. So, here we have the curve y is equal to minus x square plus 4, and this curve is y is equal to x square. So, we are getting the bounded region by these two curves as this. After that, find the intersecting point. So intersecting point is 1 is origin. What is the intersecting point over here? This curve is y is equal to minus x square plus 4. It is intersecting at the y. It means x is equal to 0. When x is equal to 0, the value of y is 4. It means this point is 0, 4. Now we need to find the intersecting points of these two curves. One, we have y is equal to x square. In second case, we have y is equal to minus x square plus 4. Substitute the value of y in this case, that is x square is equal to minus x square plus 4. This implies 2x square is equal to 4. This implies x square is equal to 2. This implies the value of x is equal to plus minus under root 2. It means again we are getting a two values of x. One is a positive of root x, another is a negative of root x. When x is equal to positive of root x, what is the value of y in this case? Either use this curve or this curve, you will get the value of y. So I'm using directly this curve. In this case, the value of y becomes 2. And when x is equal to minus root 2, y is equal to again 2. So this point is root 2 comma 2, and this point is minus root 2 comma 2. Now we are in a position to find the area bounded by these two curves. For that, we will take the double integration, the function as 1. Let's take first with respect to y, then with respect to x. In this case, first we will take a line parallel to the y-axis passing through this region from anywhere. So I have taken a two different line. One is on the negative of x-axis, another is from the positive of the x-axis. Entering curve is a y is equal to x square, and the exit curve in this case is y is equal to minus x square plus 4. And that is always fixed for every imaginary line parallel to the y-axis for this reason. So y as a lower limit is equal to x square, and y is equal to minus x square plus 4 is upper limit. Then find the limit of x. For that, we need to take the shadow on the x-axis of this region. So shadow on this x-axis, it is from here to here. From this point, the value of x is minus root 2. So minimum value of x is minus root 2. And the maximum value you will get x from this point, and that is equal to positive of root 2. This implies the value of x as minus root 2 is lower limit, and the upper limit is positive root 2. Now first take the integration with respect to y, that is y. Lower limit x square, upper limit is minus x square plus 4 and rest of the things are as it is. Substitute upper limit then minus lower limit, that is equal to this. After that simplify this, this is a minus of 2x and plus 4 as it is. Then take integration with respect to x. When you take its integration with respect to x, we have minus 2x cubed by 3 plus 4x. Then substitute upper limit minus lower limit. You have the answer as a 16 root 2 by 3 in this case. Now you can practice if you take with respect to x first, then with respect to y, what are the limits in that case? I can give you the hint. In that case, you will get a two different reason, because when you take a line parallel to the x-axis, you will get in this case as an entering curve as a y is equal to x square as well as the same as the exit curve. Whereas when you are entering through this side, you will get a entering curve as this y is equal to minus x square plus 4 and same for the exit. From here, just find the values of x and try to solve that one. Moreover, in that case, you will get the same answer. It's my suggestion, always first observe which one is comparatively easy to evaluate. And whenever you are getting a two different reasons, when you are taking the limit for any of the variable first, then try to change the order of that integration. Might be that is comparatively easy. Then now we have solved three examples that is related to the concept of area of the region. With the help of double integration, we have evaluated the area of the region by taking the function as a 1. Right now, the question is find the volume of the solid which is below this plane and above the xy plane bounded by these three curves. In this question, we need to calculate the volume instead of area. It means in double integration, we cannot take a function as a 1. There must be a function that depends upon xy variable, and then we can integrate that with respect to x and y. As per this question, function is z is equal to 2x plus 3. Why this one? Because we need to find the volume of solid below the plane this. So this is a plane, not a surface, as it is depending upon one variable. If it is depending upon two variables, then it is called as a surface. We need to find the double integration of this function over the region that is defined on the xy plane bounded by y square is equal to x is equal to 0 and x is equal to 2. Now what is a y square is equal to x? This is a parabola. Now this is parabola on which side? Right side, up side, left side or down side? As you can observe, the x is always positive whatever the value of y is. It means it is a parabola that is on the positive of the x-axis. Or we can say that it is a parabola that is of the right side. X is equal to 0, it means it is a y-axis. X is equal to 2, it is a line. Here I have taken the reason. This is a parabola that is y square is equal to x. X is equal to 0 means y-axis. X is equal to 2 is this line. We need to take a bounded region by these curves. The bounded region is this one. Now we can take the limit first with respect to x, then with respect to y, or you can take first with respect to y, then with respect to x. Let's evaluate this first with respect to x, then with respect to y. So this double integration function is 2x plus 3 dx dy. When you want to take the limit first with respect to x, we need to take a line parallel to the x-axis. So here I have taken two imaginary lines parallel to the x-axis passing through this region. In this case, this imaginary line enters the region at this point, and in the second case, this line enters the region at this point. Now these points lies on the curve y square is equal to x. It means the entering curve in this case is y square is equal to x, and in that case the value of x is equal to y square. It means it is a lower limit. Now these imaginary lines exit the region from this line, and this line is x is equal to 2. Now for y, we need to take the shadow on the y-axis. How to take that one? Suppose you are standing over here, you have a torch, put a light on this region, you will get a shadow from here to here of the region. Now what are these points? These are the intersecting points of x is equal to 2 and y square is equal to x. Let's evaluate this. When x is equal to 2 and y square is equal to x, this implies y square is equal to 2. This implies y is equal to plus minus under root of 2. It means we have two different values of y. One is a positive and second is a negative. Clearly, this point is x as a 2 and y as a root 2. Whereas this point is x is equal to 2 and y is equal to minus root 2. Now we can calculate the limit values of y. The lower limit is a minimum value and the minimum value of y is minus root 2. And the maximum value of y in this case is root 2. Now we can evaluate this double integration. First with respect to x, that is 2x square by 2 plus 3 times of x, where x is equal to y square and x is equal to 2 as a upper limit and the limit of y as it is. This is further is equal to this integration as it is. Substitute the upper limit of x, we have 4 plus 6 minus lower limit of x is y square. So we have this 2 is get cancelled with the 2. X square is y raised to power 4. In this case, plus 3 times of y square integration with respect to y. This implies integration from minus root 2 to root 2 of 4 plus 6 is 10 minus y raised to power 4 minus 3y square dy. This is equal to, now take integration with respect to y, this is 10y minus y raised to power 5 by 5 minus 3y cube by 3. Lower limit is minus root 2, upper limit is a root 2. This is equal to. In this case, this 3 is get cancelled with this. Substitute upper limit minus lower limit. This is equal to 72 root 2 by 5. And that is the final answer in this case.